Hello and welcome back. So today we'll be looking at another type of question based on trigonometric ratio of multiple angle, and here we are given our condition. This is our given condition, so let me write here given tan x is equal to k dot tan y, and what we have to prove is we have to take this left hand side of this equation and try to solve for our right hand side of this equation. So let me start from the given condition. So here is our given condition, tan x is equal to k dot tan y. Now let me divide both of both side by tan y. So tan y and tan y get cancelled out. So this implies tan x dot tan y is equal to k. So we have the value for k, which is the ratio of tan x to tan y. Now let us jump into the proof part. Let me first take my left hand side of this equation. So this is our left hand side of this equation, and let me substitute the value for k, which is found to be tan x divided by tan y plus 1, and then our formula for tan x minus y is, so sin x minus y is sin x into cos y minus cos x into sin y. Now let us put the formula here. Sin x into cos y minus cos x into sin y. Now let us take the LCM here. Tan x is tan, here we have tan y as our denominator, and here tan x plus tan y, and then the remaining term as it is. Now what we can do is we can change the value for tan x in terms of sin and cos. So we have, for tan x we can write sin x by cos x, and then for tan y we can write sin y by cos y, and let me divide this term by tan y, which is sin y by cos y, and then the remaining term I'm going to write it as it is. So cos x dot sin y. Now on further simplification, what we have is, we have here the LCM for these two terms. For the numerator part, we have cos x dot cos y as our LCM. So here we have sin x and then cos y plus sin y dot cos x divided by, finally we have your sin y by cos y, sin y divided by cos y, and then the remaining term, this one. Now if we look at this part right over here clearly, we can see that it's the formula for sin x into cos y plus cos x into sin y. It is the formula for sin x plus y. I hope you know the formula. You can see it over here as well. Sin x into cos y plus cos x into sin y is the formula for sin x plus y. So here instead I can write sin x plus y divided by cos x dot cos y, and then let me rationalize this. So cos y becomes my numerator, and here comes my denominator sin y, and then the remaining term. Now what I can do is I can simply cancel this to cos y, and then I have here sin x plus y. So if we look at my right hand side, here we've already got sin x plus y. Now we just need k minus 1. Now let us go on solving. Here we have cos x, and then we have your sin y, and then comes my remaining term sin x dot cos y minus cos x dot sin y. Now let me distribute 1 by cos x dot sin y inside this parenthesis. So I'm going to write sin x plus y as it is, and then I have sin x dot cos y, and I shall divide it by cos x dot sin y, and then minus sin cos x dot sin y, and then cos x dot sine y, since we distributed this 1 divided by cos x dot sine y for both the term inside the parenthesis, we get this term right over here. Now if we look closely, we can cancel these two terms, and we have sine x divided by cos x is simply tan x, and let me bring cos x below here. We can do it, but we have to get rid of this cos y in numerator. So divided by, we have here sine y by cos y, and it is equal to tan y, and then this term gives minus 1, and then we have from our given condition that k is equal to tan x divided by tan y. So for this tan x divided by tan y, we can simply write k from our given condition. So on rearrangement, we get k minus y and then sine x plus y. So this is our term on right hand side. So this is all we have to do in this question. I hope you got the concept for how to solve this question, and yes, thanks for watching.